In this section, we're going to talk about division of polynomials, and we start our discussion by talking about the easiest type of division, and that's division by monomials. So I want to look at first what happens if I had, for example, let's say I wrote 1 over 5 and I wanted to subtract 3 over 5. So 1/5 minus 3/5. If we were writing out every little step of subtracting fractions, we would take the numerators and combine them over the same denominator. And we would then subtract as normal. And we're going to use this concept that I can separate the numerators of a fraction into their individual and write them over as individual fractions so that we can reduce our monomials. So let's look at an example of that. This first polynomial division that I'm going to do right here, I'm going to take the first term, 10x over 6, or 10x to the 6, and write it over 5x squared. Then I take the second term, negative 40x cubed, and write that over 5x squared. So I took this division right here and I separated it into two separate fractions. And now I'm going to just reduce these two fractions to come up with an answer. So 10 divided by 5 is 2, and x to the 6th divided by x over 2, or by x to the second power, is x to the 4th, because 6 minus 2 gives me 4. And then I'm going to subtract 40 divided by 5. I get 8. X cubed over x squared leaves me with just x, because 3 minus 2 gives me 1. So you can see that my answer is 2x to the 4th minus 8x. So let's practice that again. We want to come over here and we're going to take this polynomial division and rewrite it as 6a to the 7th over negative 2a to the 7th. I'm going to take this subtraction sign as, or this sign right here as my operation, minus 10a to the 5th, and write that over a negative 2a to the 7th. So I kept the negative 2a, the negative sign with the 2a in the denominator. Let's come back and look at this fraction right here and let's reduce this. So 6 divided by negative 2 is negative 3. A to the 7th over a to the 7th is 0. It just cancels itself out, so I can leave it off. And now I'm going to say negative 10 divided by negative 2 gives me a positive 5. And a to the 5th over a to the 7th leaves me with a squared. Now you might be wondering why I took that a squared and knew to put it in the bottom. A to the 5th over a to the 7th, we use the quotient property. So I have a to the 5th minus 7. So I get a to the negative 2. And I want to always leave my exponents as positive exponents. So this could be rewritten as 1 over a squared, which is why I put it in the denominator. Another rule of thumb is I know because this is the quotient rule, I'm going to subtract, and 7 is the larger number, so I'm going to put my answer in the denominator because it goes where the larger number was. So when I separated this monomial out into fractions, I came up with this for an answer. Now let's practice that again. This time I'm going to separate my polynomial division into 3 different fractions because I have 3 different terms in the numerator. So the first one is negative 14x to the 7th over negative 2x to the 5th plus 6x to the 6th over negative 2x to the 5th minus 6x to the 5th over negative 2x to the 5th. And I want to reduce or simplify each one of these fractions. This first fraction, negative 14 over negative 2, gives me a positive 7. X to the 7th over x to the 5th leaves me with x squared, because 7 minus 5 is 2. Okay, so I have 6 divided by a negative 2 gives me negative 3. I needed to do that for the sign. X to the 6th over x to the 5th leaves me with x. And then negative 6 divided by negative 2 is a positive 3. And x to the 5th over x to the 5th leaves me, cancels out my x's. So my answer is the trinomial 7x squared minus 3x plus 3. And this is how you do division of polynomials by a monomial. So in each of these examples, you'll notice that my term that I'm dividing by is a monomial, or in other words, we have just one term in the denominator, and this is the easiest way to divide, is to just break it up into fractions and then reduce or simplify each one of your fractions.